Hey everyone, a very warm welcome back to the channel. And today we are discussing the question number 11 from the chapter of AOD, monotonicity and maxima minima. The question is asking us to prove that 1 upon sine square x is less than or equal to 1 upon x square plus 1 minus 4 by pi square for all acute x. The maximum time allotted for this question would be 12 minutes, and ideally you should try to do it within 4 minutes. So now let us discuss the solution of this question. So the concepts and formulas used are very basic. Whenever the derivative of a function is greater than 0, it implies an increasing nature of the function f of x, and method of critical points and sign scheme also we should know. Now let's see how to solve it. So the very first thing that we should be able to notice is that if I transpose this term to the left hand side, the function that we get on the left hand side is cos x square x minus 1 upon x square. Basically 1 upon sine, we are calling it as cos x. Now this function is actually, or this expression, this quantity is simply going to be f of pi by 2, because if we find f of pi by 2, that will come out to be cos x square pi by 2, which is 1, minus reciprocal of pi by 2 whole square, which is 4 by pi square. So the inequality simply is equivalent to proving that f of x is less than or equal to f of pi by 2. Now let us find the derivative of this function, which is f prime x, and that comes out to be this quantity. Finding the derivative is a very easy task. We have just used chain rule and basic differentiation rules. So using that, the derivative we have found, we shall now find the critical points of f of x by solving the equation f prime x is equal to 0. So if we are going to solve this equation by solving, derivative equal to 0, this is what we get. Then I take cube root both the sides. If I take cube root, and of course, first of all, I cross multiply, then we take the cube root, and that's how we are getting the equation number 1. I'll explain very quickly. 2 and 2 get cancelled. Then on cross multiplication, we get sine cube upon cos is equal to x cube. And then we simply take the cube root, which gives us s upon c power 1 by 3 is equal to x. And then I transpose the x to the left hand side. So very basic and simple steps. That's how we have reached the equation number 1. Now let us call this particular expression as g of x. So g of x, when we differentiate, we are getting g prime x equal to this quantity. This differentiation is very easy. We have just used the quotient rule here, and derivative of x is anyway 1. So derivative we have found to be this quantity. Now on simplifying this by taking the LCM, this is the expression that we are going to be getting. And this 3 cos square x, I am going to write as 2 cos square x plus cos square x, because cos square plus sine square will then become 1, and the remaining terms remain as it is, no change there. So this can then be written as this expression. So what we have done is, I have just taken 1 by 3 outside, like 1 by 3, and then we have just split it. So like 2 cos square upon cos power 4 by 3 plus 1 upon cos power 4 by 3. So that's how this expression we are, we have been able to write it in this form, because 2 minus 4 by 3 using the laws of exponents will become 2 by 3. So very simple and basic manipulations that we have done. Now we find g double prime x, the second derivative, right? So second derivative comes out to be this quantity. This can easily be simplified by taking cos power minus 7 by 3 common from these two terms, so that inside we'll be left with this term, okay? And this is of course sine square x, and into sine x, which is already outside, makes it sine cube x, and the remaining terms remain as it is. Clearly this expression is greater than 0 for all acute x, okay? So that means g prime is an increasing function, because g prime's derivative g double prime is always positive. So we have shown that g prime is increasing, but that would imply, since x is greater than 0 for acute x, g prime x must be greater than g prime 0 for all x in this interval, or for all acute x. But what is g prime 0? G prime 0 is 0, as can be easily noticed. So basically you just put 0 here. So g of or you can just put 0 here actually. So what are we getting? G prime x is this, right? So g prime 0 would come out to be 1/3 of 2 plus 1. The reason is cos 0 is 1, right? So that's why we have been able to write it like this. This comes out to be 0. So g prime 0 is nothing but equal to 0 only. So we have been able to prove that g prime x is greater than 0, because g prime 0 was 0, so for all acute x. So Since g prime x is greater than 0, g of x is an increasing function. And that would imply gx greater than g0 for all acute x. But g0, if we want to find from here, g0 obviously comes out to be 0. Easily you can see g0 is 0, sine 0 also 0, and x equal to also 0, right? So that's why we are getting that g of x is greater than 0 because g0 is 0. So for all acute x, so the equation number one has no roots, or it has got no roots for x belonging to 0 to pi by 2 open interval, right? The reason is we have shown that gx is always greater than 0. So how can it be equal to 0, right? So that's why it will have no roots in the given interval 0 to pi by 2. Now, so the thing is that there is no critical point of this function in 0 to pi by 2. Of what function? Look, what we are saying is that f prime x equal to 0 when we were solving, that led us to this equation. And since this equation doesn't have any roots, it means f does not have any critical points. So basically f prime x does not have any root in 0 to pi by 2. So its sign scheme will remain constant throughout 0 to pi by 2 because there is no critical point, right, in that interval. So we just find the sign of what are we finding? The sign of f prime x in the interval 0 to pi by 2. And since there is no critical point, we can find the sign of f prime at any of these points. Whatever that sign is, it will stay throughout this interval. That is precisely the method of sign scheme and critical points, right? So that's what we are doing. So what we are doing is we are finding limit x tends to pi by 2 minus. Basically, we are finding the sign of f prime x very close to pi by 2 from the left hand side, right? So it is very easy to find that. I'll explain why. So this is the expression, right? So if you put like pi by 2 minus, this will become 0, right? Because cos of pi by 2 is very close to 0 because x is tending to pi by 2 minus. So this is a number very close to 0 and this is a number very close to 1, right? So cos x tends to 0 and cot x also tends to 0. It is one and the same thing. So this expression is very close to 0, but this is a positive quantity. So it is very easy to see that the sign of f prime is actually going to be positive throughout because it is positive here. Okay, basically if there are no critical points or between any two critical points, whatever the sign scheme of a function is at any point, let's say it is positive, then it will remain positive throughout in that interval. If it is negative, then it will remain negative throughout that interval. That is the method of sign scheme and critical points. So since this is the sign scheme of f prime x, we can say that f prime x is always greater than 0. It is always positive, right? F prime x in this interval is always greater than 0. So that means f of x is increasing in this particular interval. But since x is an acute angle, or we can say that x is less than or equal to pi by 2, we can say due to the increasing nature, f of x would be less than or equal to f of pi by 2, and that pretty much sums it up. The question is solved. This is precisely what we had set out to prove, and we have been able to do it. So that pretty much, is the end of the solution. Now, what you can try is, you try it yourself, that show that g prime x, which is basically this equation, is always greater than 0 without resorting to finding g double prime x. So right now what we have done is we have basically found g double prime x, shown it to be greater than 0, and then said that g prime x equal to 0 will have no roots, but or basically it will always be greater than 0, like here we have shown, right? G prime x always greater than 0. But try to show it without using g double prime x. There's also a hint given. You can try to use critical point method for g prime x and showing that it will never be 0 and it will always be greater than 0. You can try it out yourself, and hopefully you will be able to do it, and make sure to comment down below how you were able to do it using critical points. So once again, thank you all for watching, and thank you for sticking up all the way up till the end. Make sure you like the video, comment down below what more you would like to see next. Share it with your friends, subscribe to the channel, hit the bell icon to never miss an update, and I'll see you all in the next one.